All right, today we're going to talk a little bit about the time value of money. Right, and we're going to talk a little bit about how much money is worth in the future, how to figure that out, how much money you can make, and so on and so forth. Okay, so let's go into this scenario. Suppose your brother or your sister owed you $500. Would you rather have this money repaid right away in one payment or spread out over a year in 4 installment payments? Okay, would it make a difference either way? What we're going to take a look at here is the answer. You would probably be better off getting your money right away in one payment. Okay, you could invest this money to earn interest on it, or you could use this money to pay off all or part of a loan. So if you get it back right away, it's going to be cheaper for them and better for you. The time value of money refers to the fact that the dollar in hand today is worth more than the dollar promised at some future time, and that's pretty much what you need to. Okay. Why is that true? Well, you got to recall the opportunity cost. And the opportunity cost definition is the cost of any decision includes the cost of the best foregone opportunity. For example, if you pay $10 for a movie ticket, your cost of attending the movie is not just that $10 ticket price, but also the time and cost of what else you might have enjoyed doing instead of the movie. Or if you took off a day's worth of work, your opportunity cost is those foregone wages as well. Okay, applying this concept to that $500 owed to you by your brother or your sister, you'll see that getting the money in installments will saddle you with the opportunity cost. What you're going to be doing is you're going to be giving up that $500. You're going to give that to them. Think about all the things that you could have been doing to that $500. Okay, and by taking the money over time, you lose interest on your investment. See, if you would have invested that $500 at, say, something that was earning 10%, okay, you'd be losing that $50 interest or any other use for that initial $500 on spending it on something you would have enjoyed more. Maybe you wanted a flat screen TV or something along those lines. So you're giving up that interest or that flat screen TV or that vacation or anything like that by giving them the $500. Okay? How do we figure that out? Well, the first thing you need to consider is future value. Okay, future value, or FV, as you'll see here in the rest of the book, rest of the lecture. It refers to the amount of money in which an investment will grow over a finite period of time at a given interest rate. Okay, this is where it starts getting a little mathematical. Future value is the cash value of an investment at a particular time in the future. Again, good green definition right here. Let's go back here. Sorry about that. In our example, R is 10%. And so your investment grows at 1 plus 0.1. All right, so for every dollar you invest, you make $1.1 or $1.10. All right, and in the case of this $100, you end up with 100 times 1.1 equals $110. All right, so this equation right through here is something, again, that you'll need to know when we get into the problems here in the next couple days in class. You're going to need to be familiar with that particular equation. Moving forward. Okay, if you're investing for more than one period, all right, so the last example we looked at, we're only going to invest for about a year. Okay, now we're going to invest for more than that. So now, if you keep that money in the bank, that $100 that's turned into $110, all right, if you keep that money in the bank, you're going to earn $11 interest after the second year, making it 100 plus 11 is 110 plus 11. There's a typo right there. That should be 110 plus 11 equals $121. This $121 amount is the future value of $100 in 2 years at 10%. Okay. One other way of looking at it here is that a year from now, you're effectively investing $110 at 10%. If you want to break it down into single period problems, again, that's going to be a little bit more complicated. All right, you could still use that 1.1. So if you want to go back to that equation we talked about on the last slide, you take that 1.1 or $1.10, multiply it by $110, which will equal $121. Okay, and this is again for 2 years, future value for 2 years. And we'll work on some problems in class that will kind of help you understand this. If you're a little bit confused right now, just make sure you understand the equations and kind of the process. And again, when we get into class in the next couple of days, we're going to walk through a whole bunch of problems. Okay. Good definition here. The process of leaving the initial investment plus any accumulated interest in a bank for more than one period is called compounding. You're just essentially you're letting it ride. You're moving it forward. You're not pulling the money out after a year. You're compounding it. Okay, compounding the interest means earning interest on interest, so that we call the result compound interest. Because think back to that example before. We had $110, right? And now that $10 interest, we're now going to earn interest on that interest. We're going to earn interest on that $10 interest, so that gives us $121. All right. Another definition that your book does a pretty good job of explaining is simple interest. All right, and the interest is not reinvested, so interest is earned each period on the original principal only. So let's say you pulled the $10 out at the end of that first year, right? That interest will not gain additional interest. And again, we'll make more sense of this as we move through it. But compounding interest is usually your best bet. If you leave the interest in, it'll make more money. You notice we made $10 one year, but we made $11 the next year. We made one more dollar next year. Now, that doesn't seem like a lot, but you're dealing with $100. But when you multiply that out towards millions and billions, you're talking about a lot of money. Let's take a look at this example. Suppose you locate a 2-year investment that pays 14% a year. If you invest $325, how much will you have at the end of 2 years? Well, at the end of the first year, if you multiply it out, $325 times 1 plus 0.14 will give you $370.50. All right. Now, if you reinvested this entire amount, in other words, if you reinvested this $370.50, okay, you would compound the interest, and at the end of 2 years, you will have $422.37, because we're taking that 370 in the second year, the 370.50, and multiplying it by that same equation here, which will give you 422.37. Sorry about this, guys. Acting really weird. If you take a look here, by the time it gets to the end, you're at $5 billion, all right, after 50 days. That's the power of compounding interest right there. Let's move forth. Here's a couple equations, or the big equation. Future value equals present value, within parentheses 1 plus I to the n, where future value, FV, equals PV, which is present value, interest, all right, and the number of compounding periods. This is an equation that you must know as we go forth into these problems. Okay. Give you an example. What is the future value of $34 in 5 years if the interest rate is 5%? Okay. There's the equation. $34. There's the 1 plus 0.05 to the fifth. Then you figure it out. What you do first here is you figure out the equation, then how long it's going to be, and then you multiply 34 times that number, and the future value will be $43.39. Okay. You could also do it backwards. If I give you $1,000 in 5 years, how much money should you give me now to make it fair to me? You think a good interest rate would be $6. Okay. Well, do it backwards. Future value is going to be $1,000. Right? So we need to solve for the present value. Okay, we know that 6% is going to be our interest rate. We know it's going to be 5 years. Okay, so we got $1,000 equals PV times 1.338. All right, to solve for it, we just go ahead and solve for PV. If you give me $747.38 right now, in 5 years, I will give you $1,000. Pretty interesting how that works. Okay. You get 6% interest on your money. Does that sound fair?